Here are a few review problems over some of the exponent rules that we have talked about. I want you to pause the video. I want you to work all 5 of these out, and then I want you to turn the video back on and check your work. Okay, check your answers, see if there's anything you need to correct. The only thing I really want to talk about is the one with the -7 where the base is in parentheses. That -7 is in parentheses. Make sure the -7 is in parentheses in your answer. Okay, so since the base is -7, it's got to stay in parentheses. The other one I want to make sure you understand on this one over here on the bottom right, -3 times 4 is -12. X squared times x to the -1, I add. So I got that wrong, didn't I? So that would be x to the first power, so just x, and then y to the 4th times y to the -6 would be y to the -2. So when I fix my exponent for x there, remember that negative exponent needs to go to the denominator because it is negative, and it would become y squared. So my final answer is -12x over y squared. So here is our exploration for today. I'm going to divide powers with the same base. The other day we multiplied powers with the same base. Today we're going to divide powers with the same base. We're going to do this by expanding and then simplifying and seeing if we can write it with a single exponent. So 3 to the 5th power means 3 times itself 5 times, over 3 to the 2nd power means 3 times itself twice. Now what happens here is every 3 over 3 cancels and becomes 1, right? 3 divided by 3 is 1. So that pair of 3's simplifies to 1. That pair of 3's simplifies to 1. I'm left with 3 times 3 times 3, which is 3 to the 3rd power. I'm going to do it again with these x's. I have x to the 7th power. Is that right? 1, 2, 3, 4, 5, 6, 7 over x to the 3rd power. Every x over x simplifies and becomes 1. Anything divided by itself is 1. That set simplifies. That set simplifies. I'm left with x times itself 4 times, which is x to the 4th. So what I want you to see is that this time when we're dividing, we subtract the exponents. 5 minus 2 is 3. 7 minus 3 is 4. So we subtract the exponent. The base doesn't change. So when dividing powers with the same base, the base has to match. You subtract the exponents, and the base doesn't change. So 2 to the 3rd divided by 2, remember that's a 1 there, so this would be 2 to the 3 minus 1, which is 2 squared, okay? Y to the 7th divided by y to the 6th, that would be y to the 7 minus 6. I'm dividing with the same base, so I subtract, and that would be y to the 1st, or just y. If I have 4 to the 6th divided by 4 to the 0, that would be 4 to the 6th minus 0, which is just 4 to the 6th. Again, this makes sense. 4 to the 0 is 1, right? What is anything divided by 1? Itself. So that didn't change. Some of the weird things that they can do with this, notice in this problem right here, I've got multiplication and division going on. So what you can do is take care of that multiplication on the top. X to the 4th times x squared is x to the 6th, right? When I'm multiplying with the same base, I add the exponents over x cubed. And then x to the 6th divided by x to the 3rd power. 6 minus 3 is 3. So I get x to the 3rd as my final answer. Look at the next one. Z to the fourth divided by Z to the sixth. Well, I'm dividing with the same base, so this is Z to the 4 minus 6. And what is 4 minus 6? It's negative 2. So on this case, I ended up with a negative exponent. So I'm going to do 1 over Z to the second power. So if you get a negative exponent, go ahead and fix it. Okay, look at the next one. There's actually two ways to show this next one. I'm going to show you both. You're going to get the same answer either way. So the first way is just using my division rule. When I'm dividing exponents or powers with the same base, I subtract the exponents. So this is G to the 3 minus a negative 5 because I'm subtracting the exponents. Well, minus a negative becomes plus, and this becomes G to the 8th. Now, the other way to see this is I have that negative exponent in the bottom, right? So I can rewrite that. I can move that G to the negative 5 up to the top and it become a positive 5. So I can write it as G to the third power times G to the fifth power. Well, then I'm multiplying with the same base. I add, so I would get G to the 3 plus 5, which is G to the 8th. So be careful with negatives when you're adding or subtracting. Watch your signs. Here are a couple of problems that look a little bit like the ones we did yesterday or the other day with multiplication, except now we're dividing. You see numbers, you see bases, you see exponents, and just like before, you sort of want to look at them separately. So 10x to the fifth divided by 5x squared. I want to look at my coefficients, 10 divided by 5, times I want to look at my x's. I've got x to the fifth over x squared. So 10 divided by 5 is 2, and x to the fifth divided by x squared, I'm going to do 5 minus 2, so I will get x cubed. So that simplifies to 2x to the third power. The very last one, we've got 8, a to the seventh, b squared, all divided by 2, a cubed, b. So I want you to look at the coefficients and I want you to tell me what your new coefficient's going to be. I do 8 divided by 2 and I get 4. Now I want you to look at A's. At the A's, tell me what the new exponent for A is going to be. It's a to the seventh divided by a to the third, and 7 minus 3 is 4. So my A should be a to the fourth. Now look at the B's, simplify, tell me what your new exponent is going to be. It's b squared divided by b. Remember that there's a 1 there, and 2 minus 1 is 1. So my b is just b to the first power, or b. So my final answer is 4a to the fourth, b.